So, today we are discussing about basic algorithm design techniques. We know that algorithms are unambiguous procedural solution to problems. So, how to design these algorithms? So, there are several techniques for designing an algorithm. One of the technique is brute force method. It is a method of solving the problem by trying all possible solutions until the correct one is found. So we will check until the correct solution is found. It is a simple and an easy method, but it becomes inefficient for large problems. It systematically enumerates all possible candidates for the solution and checks whether each candidate satisfies the problem statement. So it is used basically in searching, sorting and optimization. So we can now consider an example, that is string matching. If we consider a text hello world and a pattern that is we are searching for is world. So starting from the beginning of the text, that is hello world, from the beginning, that is from H, we will check if the pattern matches the substring starting from the current position. If the pattern matches, then we will return the starting position, and if does not match, then we will move to the next position in the text. That is, in this text we will then move to E. From E we will check the pattern for world. So if it is satisfied, we will return the position of E, and if it doesn't, we will move on. Continues this process until the pattern is found or until there are no more positions left to check. Our next method is divide and conquer approach. It is a simple method where we solve a problem by breaking down into smaller and manageable subproblems. So solving each independently, that is, if we are solving each subproblems independently and combining the solution, we can give the solution for the original problem. So the steps included are divide, conquer and combine. There are three main steps. First one is divide. So while dividing, we are actually breaking the problem into smaller subproblems that are similar to the original problem, but it will be smaller in size. Then we will conquer, that is, solve the subproblems recursively. If the subproblems are small enough, then we will solve them directly. The last step is combine. So we will merge the solution of the subproblems that we have obtained before. Then we will get the solution to the original problem. So it is a small example of merge sort. We have an array of digits, that is 38, 27, 43, 10. So it is a array we will split into subproblem. It is a problem which is split into subproblems, that is, it is equally divided. Then 38 and 27, the other side will be 43 and 10. Now it is again split to 38, 27. So it is the smaller size, and we will then arrange it in the ascending order. So it is 27 and 38. In the same way, in the opposite side there is 43 and 10, which is arranged into 10 and 43. Then combining this, we will get the sorted array. The next approach is branch and bound technique. It is a method which is used in combinatorial optimization problems which systematically search for the best solution. So actually we divide the problem into smaller subproblems or branches and then eliminate certain branches based on the bounds on the optimal solution. So we will have certain bounds to which we can eliminate certain branches. This process will be continued until the best solution is found or all the branches we have explored all the branches. So one of the example for branch and bound technique is knapsack problem. Coming into knapsack problem, it is actually a classic optimization problem where the goal is to maximize the total value of items placed into the knapsack without exceeding its capacity. So it can be detailed explained in with an example. Consider if we are having three items with the respective weights and values. Consider item 1, item 2 and item 3 with its weight 40, 20, 40 and values 160, 100 and 120 respectively. So the capacity of knapsack given is 70. Now we can find the solution for the fractional knapsack problem. So initially we have to note down what are the values we are given with. So first of all, W1 That is the weight 1 equal to 40, weight 2 equal to 20 and weight 3 equal to 40, as well as the values V1 equal to 160, V2 equal to 100, V3 equal to 120 and W, the capacity of knapsack is 70. So we have to compute the weight. So weight can be obtained, that is value per weight, Vi by Wi. That is, first cost is V1 by W1, that is 160 by 40 equal to 4. Next one, V2 by W2 equal to 100 by 20, that is 5. V3 by W3, 120 by 40, that is 3. So now we have to select the items with greatest value per weight. So the greatest cost is for item 2. So we will first select the item 2, that is weight is 20 and value is 100. The next smaller cost is for item 1, that is 4. So the weight is 40 and value is 160. Now we were given with a weight with a capacity, that is W equal to 70. We have initially chosen two weights, that is 20 and 40. So we only have the capacity 70. Already we have reached 60. 20 plus 40 is 60. So now we can only have 10. Then only the given capacity condition will be satisfied. So then we will take the weight 10. Also we were given that the cost for the item 3 is 3. Here weight is 10 and the cost is 3. So definitely the value will become 30. Now we can calculate the total value, that is 100 plus 160 plus 30, that is 290. Next approach is greedy approach. It is a simple and efficient strategy for solving certain optimization problems. By always choosing the best option available at each step, it can quickly produce a solution. So the key idea here is to make the best choice possible at each step without considering the previous choice. It may not always produce an optimal solution for all problems, so there's a chance only. Then one of the example is minimum spanning tree for greedy approach. So we can solve it by mainly by two methods, that is Prim's algorithm and Kruskal's algorithm. So here we are discussing to obtain this minimal spanning tree using Prim's algorithm. So this is the graph initially for which we have to find out the minimal spanning tree. The steps involved are very simple, where initially we have to select a random vertex. So here I am choosing 0. So 0 is chosen. Then from 0 we have to choose a vertex with minimum weight, the edge having minimum weight. So here from 0 the adjacent vertices are 1 and 7 with the edges weight with 4 and 8 respectively. So here the minimal weight is for the edge 4 which is directed towards 1. So we will choose the vertex 1. First step we have chosen the vertex 1 with edge weight 4. Next we will choose here we are having two vertices, that is 0 and 1 that we have chosen. So from 0 and 1, to which vertex we are having minimum weight for the edge. So here we have chosen 7. We can also choose 2 from 1. It is also having edge weight 8. So we can also choose 2. Here we are choosing 7. Now from 7, 0 and 1, to which edge we should move with the minimum weight. So here we can choose 6, which is having edge having weight 1. Continue the steps accordingly. Next we have to choose from 1, 0, 7 and 6, which is the vertex with edge having minimum weight. So we are choosing 5, which is having the weight 2. Now with the next step we are choosing vertex 2 because it is having edge with weight 4. Now we are having vertices 1, 0, 7, 6, 5, 2. Now from all these vertices, which is the edge with minimum weight? So here we can choose 8 actually, because it is having the edge with weight 2. Now from these all vertices, we can see that from 8 to 6 we are having an edge with weight 6, and from 2 to 3 it is 7. So the minimum weighted edge is from 8 to 6, but if we choose that edge it will enter into a loop. So we should not enter into a loop. Without entering into the loop we have to traverse all the edges. So we will not choose 6, we will choose 3. Now in the next step we have chosen almost all the edges, only one edge is remaining. So from which vertex to the edge 4, to the vertex 4 which is having minimum weight. So here from 3 to 4 the weight of the edge is 9, so we will choose that. Now if we are drawing only that path we have traversed for finding this minimal spanning tree, we will obtain this minimal spanning tree. It is the method using Prim's algorithm. We can also use Kruskal's algorithm. Here we are discussing about Prim's algorithm. Next method is dynamic programming. So it is a design technique which is used in optimization problems. So we know that there can be many possible solutions where each solution will have its own value, and we wish to find the solution which is having an optimal value, right? Then the development of this dynamic programming algorithm can be broken into mainly into 4 steps, that is characterizing the structure of optimal solution, then recursively defining the value of this optimal solution, compute the value of optimal solution in the bottom of the fashion, then construct the optimal solution. So mainly here from the steps 1 to 3 form the basic of dynamic programming solution to a problem. 4 can be omitted if only the value of optimal solution is required. Okay. Next method is backtracking. It is also a simple method where it is a methodical way, that is it tries out the various sequence of the decision until we find one that works. So actually it is a very slow method. It is having mainly 2 versions. One is the solutions needs only to be satisfied problem constraints, and next one is the solution needs to be optimal. The one of the example of this backtracking technique can be sum of subset problem. That is, for example, we are having n positive integers, for example w1, w2 and wn, and a positive integer s. So we have to find the subset of this w1, w2, w up to wn that sum to s. For example, we can discuss an example to understand this easily. That is, there is a given set s equal to 2, 4, 6, and w here the weight is 6, right? Then find the subset, sum of subset using backtracking approach. It is a simple method. Here n equal to 3, right? w1, w2, w3. So n equal to 3, w1 equal to 2, w2 equal to 4, w3 equal to 6. So the state space tree, we can draw the state space tree. Initially we will start with 0, and the first value here given is w1, that is 2. So we can start with 2 and 0. Okay, then we will get 0 plus 2 equal to 2 and 0 plus 0 equal to 0. Now we can use 4 and 0, right? Then now when we are using for 2, we will have 2 branches, 4 and 0, where 2 plus 4 is 6 and 2 plus 0 is 2. Similarly, for the branch 0, we will have 4 and 0, where 0 plus 4 is 4 and 0 plus 0 equal to 0. So we know that here the question is we have to obtain our value, our sum to be obtained is 6. Here we obtain 6, right? 2 plus 4 equal to 6. So we have obtained one of the sum. Now we have to obtain others also, right? Next we will check the other branches. Now we have w3 equal to 6. Here from 6 plus 6 we will get 12. 6 plus 0 equal to 6. 2 plus 6 equal to 8, 2 plus 0 equal to 2, 4 plus 6 equal to 10, 4 plus 0 equal to 4, 0 plus 6 equal to 6 and 0 plus 0 equal to 0. So, here we have found out 2 sixes, right? Initially we obtained 6 in this step where 2 plus 4 equal to 6, and from another branch we have obtained from 0 plus 6 equal to 6. So we have obtained 2 solutions, means there will be 2 subsets, and here first we have obtained 6 from 2 and 4. So one of the subset will be 2 and 4, and the next one is 6. 0 plus 6 equal to 6. So the next one is 6. The sum of the subset is 2, 4 and 6. So these are the basic design techniques that we are using for designing algorithms. Thank you.